Hey, what's up? It's Triggy. Welcome to part 2 of the robotic arm project. The plan is to control the hand that we made in part 1 with signals from the brain or from a muscle. Today, we'll see how well we can capture those signals. One way to measure brain signals is with an EEG. To get a really good measurement, we'd need dozens of electrodes and an impractical helmet for real-life use. There are, however, less intrusive devices that are still able to capture broad signals. You may have heard of some of these for use with meditation apps. This toy, MindFlex, uses such a headset, which consists of a headband with 2 clips to the ears. I think this is just about the limit in terms of what you could expect someone to actually wear. The toy measures your focus to turn on fans and move a ball around. Here you can see the fans activate when I concentrate and deactivate when I stop concentrating. At least that's how it's supposed to work. In reality, it's a lot more finicky. Let's hack into this headset to get the signal data. If we open it up, we see the data sent wirelessly to the base of the game. We can intercept this by soldering a wire to the transfer pin and another to ground. And now we have access to the serial data. If we now display this data, we see several values corresponding to activity in different wavelength ranges, as well as values for meditation and focus. It's not clear how these values are calculated, but the toy seems to use the focus value to control the fans. We can display these values graphically. The leftmost bar is focus, and I will see if I can control it. A green circle indicates that I am concentrating, and a red circle means that I am not. And as you can see, there's definitely a correlation between my focus and the movement of the bar, but honestly, it is tenuous. I have, however, noticed I get more consistent results just by raising my eyebrows. I imagine this just interferes with the signals or the connection, but notice a spike in all the wavelength values when I raise them. The real test is to see how the hand reacts. The physical hand isn't set up yet, but we'll use a virtual model we made, and write a script to have it read from the serial port and activate the hand above a certain threshold. I'll close my hand to indicate focusing, and open it to indicate not focusing so you can tell. As you can see, the correlation is even less consistent than before. It is possible to get somewhat desirable behavior, but honestly, this doesn't appear to be the best path forward. Let's see how well we can do reading muscle signals. I've got a MyoAware sensor that reads voltage across a muscle, so it can detect when the muscle is flexed. I just place one electrode at the center, one at the end of the muscle, and one at a neutral point. I can connect the power and signal wires to an Arduino, and we can see the value spikes dramatically when the muscle is flexed. And now when we try controlling the virtual hand, the response is terrific. Not to mention that the MyoAware sensor is much less intrusive than the headset. I think muscle signals are pretty clearly the winner here. Now that we have the controls figured out, next time we can focus on actuating the hand. If you want to keep up to date with this project, be sure to subscribe, and I'll see you next time.